Good day, everyone. I'm so glad that you're here today. Whether you're joining me for the first time or you're already a math wizard in the making, this lesson is for you. Today, we are going to learn something really important in algebra: how to add and subtract simple monomials. Don't worry if that sounds a little tricky right now. By the end of this lesson, you will be doing it with ease. Before we dive in, let's take a look at what we want to accomplish today. At the end of this video, you should be able to add and subtract simple monomials. That's our goal. Simple, right? Let's work toward it together. First things first, let's make sure we understand what a monomial is. A monomial is an algebraic expression that has only one term, just one. And here are some examples of monomials: 2x, 4ab, 6. Each of those is a single term, a number, a variable, or both multiplied together. Now, before we can add or subtract monomials, we need to follow two important steps. Let's go through them one by one. The very first thing we need to do is to ask ourselves, are these monomials like terms? For two monomials to be like terms, they must have the same variable, the same exponent. Both conditions must be true. Let's look at some examples to practice identifying like terms. 4x and 2x. Are they like terms? Yes. Both have the variable x, and both are raised to the first power, so they are like terms. Negative 5y squared and 3y. Are they like terms? No. Even though both have the variable y, their exponents are different. The first term has y squared, and the second y has the first power. Different exponents, not like terms. D cubed and 4d cubed. Are they like terms? Yes, same variable d and both raised to the third power. They are like terms. 9x and 3. Are they like terms? No. The first term has a variable, but the second term is just a plain number with no variable at all. So they are not like terms. Great! Now that we know how to check for like terms, let's move on to step 2. Once you've confirmed that the monomials are like terms, here's what you do. Add or subtract the numerical coefficients. Keep the variable and the exponent exactly the same. Let's see this in action. 6x plus 8x. Are they like terms? Yes, same variable x, same exponent. Then add the coefficient, which is 6 plus 8 equals 14. Keep the variable the same. So 6x plus 8x is equal to 14x. We have now here 10y squared minus 4y squared. Are they like terms? Yes, same variable y, same exponent of 2. Subtract the coefficients. 10 minus 4 equals 6. Then keep the variable and exponent the same. So, 10y squared minus 4y squared is equal to 6y squared. Now, add the following monomials. Negative 6y plus 4y. So as you can see, this one involves a negative number. So let's be extra careful. Step 1. Are they like terms? Yes, both have the variable y. Step 2. Combine the coefficient. Negative 6 plus 4. Now, when we add a negative number and a positive number, we actually subtract the smaller number from the larger. So, 6 minus 4 equals 2. Then, we copy the sign of the larger number. Since negative 6 is the larger in absolute value, our answer is negative. So negative 6y plus 4y is equal to negative 2y. Now it's your turn. Pause the video and try to answer this. 9x squared plus 3x is equal to... Ready? Let's check your answer together. Are they like terms? Let's see. They both have the variable x, but do they have the same exponent? The first term has x squared, which means x is raised to the second power. The second term has just x, which means it is raised to the first power. Different exponents, they are not like terms. So what do? We cannot combine them. We simply leave the expression exactly as it is. So 9x squared plus 3x is equal to 9x squared plus 3x. Now, let's practice some subtraction. The process is the same. We just subtract instead of add. Let's take 12x minus 7x as an example. Are they like terms? Yes. Same variable x, same exponent 1. Subtract the coefficients. 12 minus 7 equals 5. Keep the variable the same. 12x minus 7x is equal to 5x. Pause and try this one on your own.
Negative 7x squared.
Minus 5x squared is equal to... Alright, let's go through it together. Are they like terms? Yes, both have x squared. Same variable, same exponent. Now we need to subtract the coefficients. But here's the tricky part. Both coefficients are negative. We have negative 7 and negative 5. Let me introduce a helpful method called KCC, which stands for Keep, Change, Change. This is a great tool to use when you're subtracting with negative numbers. Here's how it works. K. Keep the first number the same, negative 7. C. Change the subtraction sign to addition. And then change the sign of the second number, which is from negative 5, it becomes plus negative 5. So the expression becomes from negative 7x squared minus 5x squared, it would yield to negative 7x squared plus negative 5x squared. Now both numbers are negative, so we add their absolute values. 7 plus 5 equals 12. Then we copy the negative sign because both numbers were negative. So negative 7x squared minus 5x squared is equal to negative 12x squared. Wonderful work, everyone. Let's take a moment to review everything we learned today. Here are the key things to remember. Always remember in adding and subtracting simple monomials, we first need to check if the terms are like terms. Like terms have the same variable and the same exponent. If they are like terms, we can combine them by adding or subtracting their coefficients. Always keep the variable and exponent the same after combining. If the terms are not like terms, they cannot be combined. So we just leave the expression as it is. When dealing with positive and negative numbers, we must follow the rules of integers. You may use the KCC, which stands for keep, change method for subtraction. By mastering these steps, you can simplify monomial expressions quickly and confidently. So that's it for today's lesson, everyone. You did an amazing job working through those examples. And I hope you're feeling more confident about adding and subtracting monomials. Thank you so much for watching. Keep it up, math wizards. I'm so proud of you. See you in our next lesson.